In this video, we will review linear function. Linear function is a function of the form mx plus b. Of course, we remember the most popular slope-intercept form. M represents the slope and b represents the y-intercept, meaning that the value if the input is 0, then we have a value b, y-intercept. We have also point slope form, and that form is quite popular if we know one point that satisfies the equation of the line and we possibly know the slope. Then we can get that form, and we may always convert to the form mx plus b. And one of the important things, line has a slope. We may call it rate of change. And we know that the slope is constant. Line is line. That means we have the same steepness all over the domain. Domain for the line, of course, is all of the real numbers. And that's the formula for the slope. Just the difference in y's over difference in x. Rise over run, or delta y, delta x. All of the numerators and denominators has equivalent meaning. Okay, and this is line. This how we calculating the slope, changes in y over changes in x, delta y over delta x, and y-intercept. Yeah? That means the ratio dy dx is the same over all intervals. We may also later in calculus class try to calculate the slope of the curve. But that will be a little bit more complicated process. However, we will make it simple. But in general, at the moment, we can say that for nonlinear function, the ratio dy dx changes, depending on the interval. We may pick an interval, a relatively small interval, and see how values are changing, how steep is the line. It is a curve, but if the interval is small, we may pretend that it's a line. And then we can calculate the slope of the curve over certain interval. But that's later. Let's just solve a couple of examples for the linear functions. Oh, I have one more property. When we have parallel lines, we may notice the slope is the same. Yeah, no, that's of course, because it's the same steepness, the same slope. When we have perpendicular lines, meaning that when they intersecting, they create 90 degrees angle, then the relation between these slopes is this one. And that means one slope is equal to the opposite sign of the reciprocal of the other. That means if one is 2, the other will be negative half. If one is 1/2, then the other will be negative 2. Okay, we also remember from pre-calculus that property. Okay, so now let's see. Just a couple of applications, couple of questions. Okay, example number 1. Find the equation of the line which goes through the point 3, -4 with the slope -4. Okay? And then part B, find the equation of the line which goes through 2 given points. Okay, really quick, almost no thinking. The first one, we will use the point slope form. Y minus y sub 0 equals to m minus x sub 0. X sub 0, y sub 0 is the given point. That means the y value is -4. Subtracting -4, we adding. Slope, m is slope, is actually -4. And then x sub 0 is 3. Okay, we may distribute -4 times -3. 12 minus 4, we will have +8 as a y-intercept. Yeah, you may do the arithmetic a little bit slower, but you will get the same answer, okay? No problem. Now, part B, we have 2 points. That means when we have 2 points, we can really quickly get the slope. We still don't see the y-intercept. That means we may still use the point slope form. We may pick one of the point. Okay? Let's maybe pick the first one. Y minus 1. 1 is the y value. We do not have slope yet, and subtracting -2 is adding 2. Okay, and we just need slope. And slope we can compute by taking the changes in y, changes in x. That means also make sure that you can quickly get the slope. And now we will use 2 points. Let's consider that this is the first one and this is the second one. That means we will have 5 minus 1, 1 minus -2. 4. Oh, I think I did correctly. No. X is 3 subtracting 3 plus 2. 3 plus 2, not 1. Yeah, that means this is correct. Okay, that means the slope is, I can maybe 4/5. Okay, 4/5. Let's copy. And we do not leave the final answer like this. We will distribute 4/5x. 4/5 times 2 is 8/5 minus 1. Actually, adding 1, adding 5/5, it will be 13/5. I think that's the correct answer. Slope-intercept form is a nice form for the final answer. Okay, that's we know how to get a slope, having 2 points. And we practice point slope form. Okay, example number 2. Let's see. It costs a total of C dollars to extract T tons of ore from copper mine. If C is a linear function of T, the units of a slope of line are. And this is multiple choice. We have to pick one of the answers. That's what we know. We have total cost, which depends on is the linear function of T, of tons, number of tons. And I can say slope mx plus b, but my x, my input is tons. And this is slope. That's the slope. And we know we can always think in our standard notation dy dx. That's when we may say that this is like the changes in cost over changes in tons. Yeah, I can say changes in dollars and changes in tons. Okay, that's we have the answer. We have the answer. Dollars over the tons. We can see step by step, we can figure out. Yeah, but always think about dy dx, rise over run, dy dx, the rate of change of the value of the function with respect to the variable, the independent variable. Okay? Done? Number 3, example number 3. Determine whether there exists a constant c such that the line cx minus 2y equals to 4. And now it's not a multiple choice. We have to figure out if this line can be, if we have the value of c. Then what is the value of c? If any, that the slope of the line is 4, the line passes through the point 1, -4, the line is horizontal, and the line is vertical. Okay, let's see. Okay, that's me now part A. Slope must be 4. Okay, that's what we may do. We may try to, actually I can rearrange, let's solve, because we don't know exactly what's the formula. If I will solve this equation to the form mx plus b, I will solve for y. I will also isolate y. Subtracting cx from both sides and dividing by -2. It will be negative over negative will be positive, c over 2x, and dividing by -2, we will have 4 over -2, -2. Okay, that means it looks like c over 2 is a slope. That means c over 2, oh, too fast. Oh, why I'm not writing? C over 2 must be 4. Okay, no problem, we can solve it. If C is 8, then the slope is 4. Okay, that's when we do have a value. Slope is 4 if C is 8. Now B, a line must go through 1, -4. Yeah? Then if Y is -4, we can also use that form. Okay. That means we want y to be -4, we want x to be 1, and we can solve it for c. I think it is, yeah, it has the solution. Let's add 2 to the both side. We will have -2 c over 2. C is basically -4. If c is -4, the line passes through the point 1, -4. Not a problem. Now horizontal line. What is the slope of the horizontal lines? Horizontal. Slope is 0. Slope is 0. And I can take this c because this is slope. Yes, it's 0. This expression is 0 if c is 0. Okay, that means it's just a coincidence that c is 0, but this is important. Please remember for the horizontal lines, slope is 0. We will have lots of questions for the horizontal line, horizontal specific line. I will say tangent line. So always remember slope 0. Quite good concept in calculus class. Okay, and then vertical. Vertical, we know that vertical lines, they do not have slope. Let's say slope does not exist. I mean, looking at this expression, c over 2, can we find this expression is actually defined for each real number. C could be real number and it will always be defined. Unless we will say C is approaching like infinity, but that's not really the situation. So we can say that with this equation, the line is never vertical. Right? That means we do not have, see, like we have no, I can say no solution. Yes, no solutions because this expression is always defined. Yes, C could be any real number, and then we will, I mean, then it's always defined. That means this line is never vertical. Let me say this. This line is never vertical. Okay? Because C is a real number and slope is a real. If this will be 2 over C, like let's say 2 over C, and then for what values of C, this expression is not defined. It's not defined at 0. Then let's reverse it. If C is 0, this expression is undefined. Because we cannot really have 0 in the denominator. If it's undefined and this is slope, then the line is vertical. Yes, the line is vertical. That means we don't know. Unless, because we also know, actually, however, let's check something. The vertical lines has the equation x equals to a constant. Let's say, because I don't want to use, let's say d. And then that's the vertical lines. Like if x is equal to 1 or 2 or -1, -2, that's the vertical lines. That means let's maybe solve this equation for x. We will have cx minus 2y, and let's see what's happened. we will have cx 4 minus 2y, and then we may divide by c. Okay. No, actually, but if c is 0, then it's constant. And we just want, yeah, if c is 0, it's a horizontal. We know that it's horizontal. That's this expression is defined for all of the numbers, but not for 0. Not for 0 because we actually dividing by c. Then what we will do, if c, yeah, that means c is definitely not 0. Yeah, because we do have reserved 0. Let me remove this because this was just an example. And actually this can stay because c is not 0, because I did divide. Yes, otherwise. And now this is, we can see if this is the line, we have the y expression. Y could be any number. Yeah, that means y could be any number, and it's a variable, it's changing. That means it's not a constant. That means this x, it's not that expression, it's not a constant like we were expecting. That depends on y. Yeah? But again, I did divide both sides by c, assuming that c is not 0. That's means I'm excluding 0 because 0 is reserved for the horizontal case. But this is also like one proof, like proving that the x equation depends on y. Yeah, it's changing. Then it's not a constant, then it's never, this line is never vertical. Okay, that's kind of like 2 ways to prove this. Okay, let's keep moving. Okay, example number 4. Okay, we do have a data in the table, and which of the following tables could represent a linear function? We know a linear function has a constant, yes, constant slope, meaning that the difference in y's values are always constant for the equal differences in x. I mean, we do have, let's check, x is jumping from 0, 1, 2, 3 by 1. Okay, 15, 20, 25, 30. Okay, by 5, that's when we have no problem with x. 1, 2, 3, 4. Okay. So now let's just check what are the differences in y's. 27 goes to 25. Okay, we subtracting 2. We subtracting 2, and we subtracting 2. Okay, so we may see, yes, the difference in x. That means in order to find the slope, because it looks like the difference in y's is constant between each values, we can have delta y over delta x. And with delta x, we just jumping by 1, yeah? And we just decreasing by 2, -2. That means slope is -2. Also, if we will take 2 points, yeah? For instance, 0.27 and 1.25, we may also compute the slope. And that means slope will be y2 minus y1, 25 minus 27, and 1 minus 0, 1. The same thing. Okay, but we know the difference. Okay, that means yes, this is the linear. Let's check the second one. We're jumping by 5 in x, but the same, yes, the equal differences in x. And let's see, 62, 72, we adding 10. We adding 10, we adding 10. Okay, we know the slope. Oh, wait a minute. That's me. Now let's see what's the slope. Changes in y, changes in x. That means changes in y, we adding 10. That means we rise by 10, rise over run, and run is actually 5. That means slope is 2 because we can see 15, 20, 25, 30. Right? It's sloped. Also, if we take 2 points and get slope of getting the difference between y's and x, we will get to. Okay, this is linear relation. And what about the last one? 1, 2, 3, 4. However, changes in y's. We adding 5. We adding 8. We adding 10. It's different relation. We don't know. We may check later. Maybe it's exponential. Maybe it's logarithmic. Will be not easy to figure out, but different. Yes, different. Maybe quadratic. Maybe different powers. But at the moment, we will not try to figure out what is the relation. We definitely know that it's not linear because the difference in y's are not constant for the equal differences in x. Okay, good. Now, okay, couple of applications, then you will practice. Okay, let's see if we can create. Probably all of my applications will be just getting a line, equation of the line, mx plus b. In 2015, the population of a particular city was 2 million people. Between 2015 and 2020, the population was increasing at the rate 200,000 people per year. That means I will say, yeah, this is the slope. Find a function, population of time, yeah, P of t, the population in millions, million has 6 zeros, of the city Y years between 2015 and 2020. That means 2015 we can consider as an initial value. That means time 0, 5 years later, it will be 2020, then time is 5. Okay. That's what we can say. We know that it's a linear relation. It will be mx, but x is time, plus b. We know the slope. Yeah, slope is actually the rate of change of this population is 200,000 people per year, but in millions, when I move 6 decimal points, it will be 0.2 people per 1 year. People per 1 year. Okay, so we can see it will be 0.2 t. And then what is the y-intercept? We know, yes, yes, we don't know, or maybe we do know. Actually, we know, because y-intercept, yes, b is the y-intercept. Usually b is calculated at the time 0, because when we substitute instead of t0, it will be just b. And we know that the point, yes, at the time 0, actually p, meaning in 2015, the population of that city was 2 millions. 2 millions, which actually I can say 2. Okay, that means B is 2. Done. Probably you can solve it much, much faster than me. I hope. And this only works because this is the data, only works if time is between 0 and 5 years, because that's the only data that we have. Okay, excellent. Let's look at the next one. Similar things. Maybe I can leave it for you. What you can do, you can definitely pause the video at the moment, okay, and try to solve it, and then put the video back again and see if we match the solutions. Okay, if f of t be the population in thousands, now it's thousands of people of US city, as a function of time, t in years, where t equals to 0 corresponds to 2020. Okay, that's me now. In 2020, the population was 24,000, and each year the population increases by 2,000 people. Okay, that's I see we have a slope, and I see we have a y-intercept. That's actually done. do we have? We have to find a model the population. Please do not be like afraid of the word model. It's just like a function, equation. Model the population by finding the formula f of t. And that means the population in time. We will need mx plus b, mt plus b, and we know that this is slope is, yes, is increasing, then it's positive, 2,000 people, that means just 2. Yes, I can say slope is 2 because it's in thousands. 2t plus, it means slope is 2 in thousands, of course, and the value at 0 is 24,000. Just this, done. Okay, this is our model. I hope you also got this one. B, the part B, evaluate the expression f of 6 and write the sentence explaining what this means. 6, that means what is actually, we just need to find out what is the population 6 years later, after, yes, because this is 0 represents to 2020. Yes, time is 0. That means this will be 2 times 6 plus 24. I think it's 36, but it's in thousands. We can say that in, what is the sentence? In 2026, because it's 6, the population is or will be 36,000 people. In 2026, population will be 36,000 people. Perfect. Now solve the equation f of t equals to 60 and write the explanation. Okay, that means what we have to do, the f of t must be 60, then 2t plus 24 must be 60. And when we solve for t, we will subtract 24, 60, 36 divided by 2, 18. Okay, so what we can say, t is 18 years later after 2020. I mean, what is the explanation? We can say the same way. In 2038, because we're adding 18 to the initial time, 2020, the population will be 60. Population will be 60,000 people. Perfect. I hope you have the same answer. Okay, let's keep moving because I have a couple of, you may pause the video completely and come back again if you would like to review a linear function, but make sure that you know all of the questions. Okay, pause it here. Okay, let's see what we have. Example number 7. Alex drove from a city A up to the city B. When he arrived in city B after 1.5 hours of driving, his altitude was 710 meters above sea level. His altitude increased, important information, at the constant rate of 740 meters per hour. Really nice information. I can even write, can't stop myself. 740, it will be the slope, meters per hour, distance over the time, speed. Let y represents Alex's altitude in meters relative to the sea level after x hours. Find the equation of the relationship between the altitude and the number of hours. And that's, we can say the altitude with respect to time, I mean it will be slope, time, and y-intercept. We know slope, because it's 740 meters per hour. And then we just need B, we just need the y-intercept. But what information we have? Oh, we may, it's just enough if we have 1 point given. I mean, we may solve it for different, yes, I mean, we may have different approach, but I see some important information. After 1.5 hours driving, his altitude was 710 meters. I mean, I will assume that 1 point, which actually is, yeah, point, I can use point, is 1.5 and 710. So now I can actually use point slope form. Yeah. Let me use, and then we will see I will use just not to be confused, I can use my standard notation, X and Y's, then we will never make mistake. And then Y value is 710, slope is 740, and X is, let me put 3/2. Okay, 3/2, because then will be easier. We're not allowed to use the calculators. And then let's solve it for Y. 740x, 740 times 3/2 and plus 710. So this number is a y-intercept. Yeah, that's also a little bit different way to get this. Okay, 740 we can divide by 2, will be 370, and multiply by 3, 1110, plus 710, it will be 400. You may do your math, but do not use the calculator. I think I did correctly. It will be 400. I mean, I can erase this, and this is our model. Modeling the relation between the altitude. Actually, it will be negative. Okay, negative. Okay. I think this is correct. Okay, great. Let's keep moving. Okay, another one. However, let me, okay, you may pause the video, but what I can do, let's check the solution later in my PDF file, because for each video, I always provide a PDF file with solutions. I will, because it's getting like longer, we all know how to create the linear function, mx plus b, or maybe point slope form. I will leave it this one for you, really, really quick. Slope is given and the point is given. Use the point slope form. Okay, good. Let's see the next one. It is point given and slope. Maybe I can also leave it for you, because we have we can see $9 for each hour of work. That's when this looks like, yes, looks like the slope, and also the point is given. Point slope, yes, because at 3 hour total fee for 3 hours job. Yes, for 3 hours, we may get $33. That's mean point and slope is given. Okay, I will also leave it for you. Check my PDF later. Okay. Let's solve this one. Let's solve this one, and I think one more. Okay? Then I will finish the session. You can enjoy but definitely check all of the questions. Okay. Mark is a stunt driver on time during a gig where he escaped from a building about to explode. He drove at the constant speed to get to the safe zone that was 160 meters away, okay, from the building. Okay, after 3 seconds of driving, he was 85 meters away from the safe zone. Let y represents the distance in meters from the safe zone after x seconds. Find the equation for the relationship between the distance and the number of seconds. Okay, As we can see y, okay, y with respect to time. Time is in seconds. We know that it's linear because it's the constant speed. I mean, we will say mx, mt plus b. Do we know the slope? Do we know the y-intercept? We probably know the y-intercept because at the total distance, yes, what is the total distance away? That means at the zero time, he had the distance to reach the safe zone, 160 meters. Okay, that's we know that this is definitely, I can say this at zero time is 160 meters. That means we definitely have 160. But what is the slope? What is the actually, because this is distance over the time. Y is distance, time, t is time. I mean, and what we actually doing, we getting closer and closer. That's when we decreasing that 160. Yes, because when we are here, we have to reach this safe zone 106. That's when we're getting closer. The slope, the speed will be, this rate of change of the distance with respect to time will be negative. But how we can do? We may actually, maybe we have another point. Let's look at this. After 3 seconds of driving, he was 85 meters away. That means that's actually nothing but just at 3 was 85 meters away. Okay, we may use this to compute the slope. Okay, we may use to compute the slope. It will be difference in y's, 85 minus 60, difference in distances, and 3 minus 0, which of course is delta y over delta x. And this is slope. No, I'm just squeezing this. It will be negative 75 divided by 3. Okay, it's negative 25 and meters per second. Okay, that's the slope. The equation is set. And makes sense. Yes, makes sense because we decreasing that distance from the building to the safety zone 160. Also, we may think from that, yes, from that sentence, we don't even have to, I mean, we will use the 60, but if we know that, like, we can get the speed, yes, because we know that speed, which actually is speed, yeah, which speed is always positive. Velocity, yes, velocity is more appropriate. But let's say slope. Let's say slope in this situation is the velocity, and it's actually distance, yes, over the time. That's we can see in 3 seconds, yes, in 3 seconds, what was the distance that he actually passed? After 3 seconds of driving, he was 85 meters away from the safety zone. That's meaning that from the building, yes, if this is 0, this is 160, and this distance was 85 meters, then he actually traveled that distance in 3 seconds. And this distance is nothing different than we just have that value, 160 minus 85, which is 75 meters. Yeah, that means 75 meters in 3 seconds. It is 25, but we know that we're decreasing. Yes, we know that we're decreasing. That means we just have to put negative because we're getting closer. Yeah, that means this maybe is another way to get but more like official, it will be this. We have 2 points, we can get the slope, we know y-intercept, done. Okay, one more. But I have more questions, but you will check the solutions, right? You will check this. I have this one It's also a point slope you can get easily. I have this one. You can also try because they are nice questions. Okay, we know how to do this. I was thinking to solve this one, the last one. Oh, actually, no, I was thinking to solve number 16. Okay, let's solve number 16 because then it's too, yes, it's too long. And number 15, it's relatively easy. You can get the answer. Okay, let's just do this one really quickly. Let's get the question. It's probably the same thing, but let's just finish the session with this question. A student club is selling t-shirts for Thon every weekend. They found that when selling shirts for $10 each, they sell 500 shirts on the given weekend. However, that found over the years that every $1 price increase resulted in 10 fewer shirts being sold on a given weekend. Find a formula for a demand function. Number of shirts depending on price. That means the demand function gives number of shirts sold as a function of price. Okay, that's what we know. Okay, we have to find, let's say, number depends on price. That's we will have slope, price, and plus like y-intercept. Let's just say, yeah, 0. Like we don't know what is actually y-intercept. But we will use maybe, let's see what we know. That's the point, yes, if we would like to say like the point, we will need dollars, okay, and then number. That's when you have to be careful because this is price and this is number. That's how the demand function is. Okay, that's what we know. If the t-shirt cost $10, then the selling amount is 500. We have 1 point. Let's call it B. When now the second sentence, I mean the third sentence, if they increase the price $11, they actually selling, oh, am I right? Oh, it's supposed to be, oh, no, 10 fewer, okay, 10 fewer, it will be 490. Okay, that's me, no problem. As soon as we have 2 points, we can find slope, the rate of change of this, which will be the difference in numbers over difference in price. Okay, what's the difference in numbers? Let's be consistent. Oh, 490 minus 500, and then 11 minus 10. Okay, we will have negative 10. It will be negative 10. That means they losing $10, which again, 10, yes, increase. Oh, no, the price increase. No. In 10 fewer shirts being sold on the given weekend. That means this 10, probably most of you will tell me that that's the slope. We're selling 10 fewer, negative 10 is the slope. Yeah, because we can see negative 10 number of shirts over the dollars. Okay. Then slope is negative 10, the rate of change, it's negative 10. And, oh, what is the y-intercept? Having a slope and point, we even have 2 points, we can use point slope. Or we can calculate easily, but let's actually do this. Y minus y sub 0, slope x sub 0. Then you will have this. And let's use maybe point A. 500, negative 10, and then 10. Because we have to use 10 for the x. Okay, let's solve it for y. Negative 10 times x, negative 10 times negative 10, positive 100, and positive 500. This is 600. I mean, this is our working station. 600 is the y-intercept. That means that's the model. Okay? That's the model. That's actually the demand function, negative 10p plus 600. Okay, I think going through all of the 16 problems carefully and solving the one that I didn't solve, you will check the PDF file, you will be an expert with linear function, and then we can take this knowledge and apply in our calculus class. Okay, thank you.